Hi, I'm Xinlin Peng. I'm engineer manager at Uber today. I'm very excited to talk about Sentinel. Before we jump into the topic, here's some background about my team. My team is a mobile data platform. We focus on mobile observability for Uber applications. We empower teams with reliable and actionable insights to drive data-driven decisions. We aim to lead in data quality, coverage, and innovation. Sentinel is a Uber in-house platform built to monitor key customer experience using analytics events across granular dimensions. We built Sentinel to help us quickly and automatically detect consumer impacting incidents. The first question to ask is, what data to monitor consumer experience? At Uber today, we produce mobile analytics events when customers interact with our mobile applications. Our hypothesis is that if there are any production incidents that degrade the consumer experience, we should be able to tell from the mobile analytics. So mobile analytics is the source of truth to measure consumer experience. Now, we have a mobile analytics events. How do we monitor the consumer experience? A single user action, for example, go online for earners, has analytic events associated with it. We can monitor the volume of the event directly or via week-over-week comparisons where we found out that having a conversion rate, which is the measure of how many people convert from step A to step B, is a much better matrix than simple volume tracking. This is because the conversion rate can normalize the matrix much better than other methods and has stable daily and weekly patterns. In this case, measuring the number of go online failures by number of go online requests provides a very accurate measure of what is happening. Most common type of conversion rate are error rate and success rate. From the right side, you can see just one example. If you use the volume, it's very hard to tell from the A and B. It's very hard to tell you whether those are incidents or not. Particularly from B, you will see two tiny spikes there. But actually, it turns out that there's only one instance if you look at the conversion rate. On a high level, we have three modules in the system. The metric computation module, we use mobile analytics to generate a real-time metrics conversion rate. Anomaly detection module, which uses machine learning model to predict threshold based on the historic data. The next is the alerting module, which sends notification to engineers or product owners when the threshold get breached. Monitor conversion rate for mobile analytics events is already done by lots of teams at Uber for global metrics. The question now is how do we slice the data and set up alerts so that we can find the missing instants which are not detected by the global alerts. There are quite a lot of important dimensions which can be used for monitoring. For example, system, you can system level, you can have the city level, you can have the application version. On the business side, you can have different products, UberX, other products. We found that having city level monitoring by default is very useful in catching a large number of missing instances. And this is also easily scaled to all of the important user experience. And we started with top 100 cities. The example on the right shows an instance when only taxi drivers were unable to go online in Tokyo. We were still able to catch this issue without directly monitoring the taxi products. The system is extendable so that we can also monitor on any other dimension than city or combine city with other dimension like platform as well. So now we have decided to add city level monitoring of conversion rate. Let's take an example of the error rate while booking rides. As you can see, each city has a very different pattern of the conversion rate. Each city has its own marketplace dynamics. When you want to expand a matrix to hundreds of cities, it is critical that you are able to predict effective thresholds. And these need to be dynamic. That is that they have to be updated regularly. So when a new feature is launched, the thresholds adapt automatically. This ensures that there's a very low maintenance on the teams once these alerts have been set up. We feed historical data to machine learning model and use it to get threshold for the next day. Thresholds are updated every day. When incidents happen, the threshold get impact because the bad data will be fed into the models. So when you get a PagerDuty ticket and you annotate the alert as accurate and actionable, we automatically remove the bad data from the training, so the threshold remains stable. If you annotated them as anything else, the threshold automatically adapt to the new trend. Let's zoom into the feedback loop. The graph here demonstrates the alert lifecycle. I want to highlight two parts here. The red dot line is the threshold generated by anomaly detection engine, daily updated. If the alert is annotated with true anomaly, feedback loop will clean up the data points in the red area to prevent them contaminating the training data sets. Now, the problems left, how do we get the historical data to generate this threshold and then detect anomaly in real time? Uber already has great infrastructure tooling to solve this problem. M3 is a time series database that also supports real-time queries and computation. We can calculate conversion rate on the fly with M3 and also get historical data for the threshold prediction. Similarly, Pinot is also a real-time analytics data store which can be used for this purpose. Umonitor, which is an alerting engine for Uber, is also integrated with M3 and Pinot. And given the conversion rate and the threshold, it can detect and notify of anomalies in real time. Now, when you are tracking the same metrics across hundreds of cities, you want also streamline notifications. You can choose to be paged only when the matrix is impacted globally, or when a certain number of cities are impacted. For example, when just a single city shows a problem, you can have it either as a Slack message or email. And when two or more cities are impacted at the same time, you can choose to be paged. And even within cities, you can have different strategies. For example, get paged only for some city and the Slack for the other city. With all this implemented, we were able to catch issues in real time and provide value to Uber. However, our signal to noise ratio was around 50%, and the product team weren't comfortable with enable pages on this. We identified a couple of good ways to further improve the signal to noise ratio when you have alerts at the city level. Sometimes just a single user can generate so many events that it can trigger the alert. And this was usually not interesting for the product teams. In the graph above, you can see the red time series has a clear spike. So we decided to dedupe the events by each user in real time. We call this unique user matrix. With this, we produce the blue time series shown above, which is even more stable. You can set up alerts directly on this matrix and get paged only when a certain number of users are impacted within a fixed time window. Another reason for noise is when the traffic volume becomes very low. There are a lot of products which have well-defined operating times and have very low volume outside of these operating hours. To avoid alerts get triggered during these low volume times, we automatically determine a filter value based on the historic metric data and turn off the alerts when the volume is lower than the value. In the above case, the alerts are only enabled during the red region. By default, we turn off the alerts for a max of 8 hours per day. Here is an example that alert get triggered. We can clearly see that 13 out of 189 cities get impacted. Drivers in these cities could not go online successfully. Even though multiple cities were impacted, only 2 pages were generated. A low urgency page was generated for the first impacted city. When additional cities were impacted, a higher urgency page was generated. This was possible because of the flexible notification strategy supported by Sentinel. The uniqueness metrics generated by Sentinel were also helpful in providing additional insights into the impact analysis. For some impacted cities, we can clearly see that around 70% of the total drivers in these cities failed to go online during the instance. And however, at the global level, the percentage was just 4.5%. After we built Sentinel, so far, we caught 14 production instances, and we also prevented 9 potential instances. And we put a lot of efforts to maintain our accuracy. That's the signal to noise ratio. Yeah, this is basically our presentation. 2 key takeaways. when you build new products. I think first need to really to think about major what impact customer experience. The next takeaway is to set up clear goals and continuously iterate on the system. Thank you.